These would be the notes for absolute value equations. There is a PDF copy available online if you'd like to print one out. First thing we're going to talk about is what is an absolute value equation. Any equation that contains an absolute value expression is an absolute value equation. Keep in mind though that absolute value measures the distance something is from zero. For example, the double bar means absolute value. Absolute value of x equals 7. This means they want to know what is the distance of x from 0. The distance, I should say, is 7. Therefore, the absolute value of x equaling 7 has a value of x that is 7 and negative 7. And we should probably put the word or here for now. Okay, so 7 or negative 7. Important though, we're going to see this here in a moment. The absolute value expression, that's this part inside the absolute value itself, must be isolated before it can equal the positive and negative values. So if I have anything going on outside of my absolute value bars, I got to get rid of them, move them to the other side. I have to isolate the absolute value as if it were one giant variable. The absolute value equation, like this, ax plus b equals c, where you have absolute value of everything inside there. Where x is greater than 0, and this is very important here, x has to be greater than 0. Oops, I'm sorry, that's a mistake. Should probably reprint that. That should be c is greater than 0. Okay, c has got to be greater than 0. This value over here has to be greater than 0 because greater than or equal to 0 because you cannot have an absolute value that comes out to a negative. Remember, it's how far from 0 a number is. So that could be a plus b is equal to c, or it could be a plus b is equal to the opposite of c, also mentioned as negative c. Okay, so don't forget to change that x that was there to a c. I will change that in the notes before uploading. Example number 1, solve. The absolute value of x minus 3 has to equal 8. Well, this value right here could either equal 8 or it could equal negative 8. So what we're going to do is solve two different equations, one that's equal to 8 and one that is equal to negative 8. Since this value right here could be either 8 or it could be negative 8, we're going to solve both. So we're going to add 3 to both sides so that x will end up equaling 11 is one possibility. Or add 3 to both sides and x ends up equaling negative 5 is our other possibility. So the value here for x could either equal 11 or it could equal negative 5. So 11 minus 3 is 8. Absolute value of 8 is 8. Negative 5 minus 3 is negative 8. And the absolute value of negative 8 is still 8. So it works for both. Next example here, you'll see that I have a times on the outside and a minus on the outside. Even though we treat absolute value bars like a grouping symbol, you cannot distribute inside of your absolute value. This right here, you cannot do, so don't try to do that. What we need to do is isolate the absolute value itself. So I have to get rid of my minus, I have to get rid of my times first. Okay, so we're still going to do reverse PEMDAs here, so I'm going to add 5 to both sides. So I'm going to bring down my 3 times the absolute value of 2x minus 7 is equal to 9. I'm going to divide by 3 on both sides. So now I have the absolute value of 2x minus 7 is equal to 3. Now that my absolute value has been isolated, I take this expression here and let it equal the 3 and the negative 3, not the 4 and the negative 4. Because the value inside of this expression could either be a 3 or it could be a negative 3. The absolute value of both would give us this. So we let this expression equal 3 and we let it equal negative 3 and we solve both of them. So 2x minus 7 is equal to 3 or 2x minus 7 is equal to negative 3. And then solve for both. So plus 7 gives you 2x is equal to 10. Divide by 2. divided by 2, x is equal to 5, or, let's come straight down, or plus 7, 2x is equal to positive, not negative, positive 4, divide by 2, x could equal positive 2. So x could equal 5 or x could equal positive 2. And the only way to be certain is to put 5 in here and check it, make sure it equals 4. Put 2 in there and check to make sure it equals 4. We're going to try it real quick. 2 times 5 is 10. 10 minus 7 is 3. 3 times 3 is 9. 9 minus 5 is 4 because the absolute value of 3 is 3. We're going to put a 2 in there. 2 times 2 is 4. 4 minus 7 is negative 3, but the absolute value of negative 3 is still positive 3. 3 times 3 is 9. 9 minus 5 gives you 4 again. Go ahead and try and solve this one. We're going to see this is kind of a special case scenario here. So we're going to we're going to minus 6 from both sides. So we have an absolute value of 3x plus 5 is equal to negative 8. And at this point right here, we have an absolute value that's equal to a negative. And we said before that absolute values cannot equal a negative, therefore there is no solution to this problem. Absolute deviation. This is relatively easy, but some people have a difficult time with it. The absolute deviation of a number x from a given value, they have to give you something to start with, is the absolute value of the difference. Difference means minus of x and the given value. And here's the general absolute deviation equation where we have some deviation or some error, as we're going to find out here in a minute, is equal to the absolute value of the difference between our number that we have minus our given value. Another way to think of absolute deviation is the over and under, kind of like in scoring values of a given situation. Another name for absolute deviation is absolute error. So right now, absolute deviation, absolute error are interchangeable. I can take this out and put absolute error in its place. Example number 4. Before the start of a professional basketball game, a basketball must be inflated to an air pressure of 8 pounds per square inch. 8 pounds per square inch. This is our given value with an absolute error of 0.5 psi. That means it could be over or under by 0.5 psi, but this is the given amount. Find the minimum and the maximum acceptable air pressure for the basketball. Absolute deviation or error, in this case, is 0.5. So 0.5 is going to equal. And in place of x, I'm going to put p because I'm talking about air pressure. And minus my given value of 8 pounds. So it's got to be within 0.5 psi of an 8 pound pressure. So since my absolute value has been isolated already, I'm going to solve this as 0.5 is equal to p minus 8, or 0.5, negative 0.5 is equal to p minus 8. And then I'm going to solve them both. So I'm going to add 8 to both sides so that air pressure 1 could be 8.5. And air pressure number 2, so I'm still going to add 8 on both sides. Air pressure number 2 could be 7.5. And they want a minimum and a maximum. So the minimum would be 7.5, the maximum would be 8.5. And if we wanted to, we could write this as one compound inequality where the air pressure, whatever it may be, has to be greater than or equal to the minimum of 7.5, and at the same time less than or equal to the maximum of 8.5. And we could go ahead and graph that if we were asked to do so.